Oops. Okay, so we are going to talk about how to make a 3D solid by rotating the 2D base around a line. We already did cross sections, so hopefully you really get that. This is not totally different, but there are some real key differences, especially in what actual shape you make and how you find the volume. All right, it all starts with how do you make that base, all right, the 7.1. All right, so if you rotate around the x-axis or any horizontal line, which would be y equals any number, okay, which this is kind of confusing because you see the y equals, you might think you're doing with respect to y, but you're doing with respect to x. So imagine an x-axis or any other horizontal line. If you rotated this way, that would be like a vertical rotation. That's why we're doing with respect to x for those problems. Okay, as opposed to if you rotate around the y-axis or any vertical line, which would be x equals a number, if you rotated this way, okay, that would be like a horizontal rotation. The rotation itself would be horizontal. That's going to be with respect to y. All right, so with these problems, some of them are with respect to x, some are with respect to y. We've done that this whole time, all right? Now, instead of giving you cross-section shapes, you have two options. If when you revolve, your figure is completely solid, and I'm going to kind of show you what I mean here, then all of those inside shapes are going to be circles. What is the area of one circle?
Pi r squared.
Pi r squared. And that r is the exact same thing that we dealt with s in the previous unit. Or not unit, but what we did with cross sections. Okay, washers, definitely a little bit more complicated. They're different, okay? This happens when you revolve, and the shape that you're revolving is there's some kind of gap or hole, or there's something where you have an empty space in the middle once you rotate that around. In this case, you're going to have a big R and then a little r. Okay, and we talked about this last week. The area of the big circle would be pi big R squared, and then we just subtract out that gap. And what we're going to do actually is even factor out the pi. And if you notice, pi is part of both of these. So every revolution problem is going to have pi in it. That's great to know if you're doing matching or multiple choice. That's a great thing to know how to simplify something down or get rid of wrong answers. Everything we do here is going to have a pi in it because it's going to be all about circles. All right, so let's go ahead and start with something that we're familiar with, okay, which would be y equals square root of x. Let's go ahead and graph this. All right, 0, 0, 1, 1, and then the next point we could graph would be 4, 2. We could keep going, but considering that y equals 0, which is the same as the x-axis, and x equals 4, since this is another boundary here, I'm going to stop there and let's go ahead and review how to find area of that shape, because I want to lead you into showing you that volume, it has a lot to do with how we found area. Okay, so let's start with respect to x. This tells us to do it both ways. With area, you always get to choose which way you do it. And you should get the same answer either way, it's just usually one of them is much easier than the other. With volume, you're told which way to do it, and you got to do it that way, depending upon the problem. So, first thing, we got to know the bounds. Okay, so this is review right here. This is basically 7.1. So what are the x boundaries?
0, 4.
X equals 0 and x equals 4. Okay, so 0 to 4. And then we need to subtract the top curve, which is square root of x, minus the bottom curve, which is y equals 0. You don't need the minus 0, right? You could totally leave that off and it would be equivalent, and there you'd have your answer. And I'm not going to show the calculator a lot in today's lesson because I want to really talk more about the calculus and setting things up. Okay, so that's 16/3. Now, if we decided to do this problem, well, and they tell us to go ahead and do this with respect to y, and this is going to help us with the second part of this problem. So this isn't just for nothing, but we should get the same answer, 16/3, and we will. All right, first thing is we have to find the bounds that are going to be different. They're not going to be x values. They're going to be y values. So go ahead and see if you can set that part up. Okay, so what were your bounds? 0 to 2. Okay, because those are the y values. Y equals 2, y equals 0. All right, and then could we use square root of x? No, we can't. That's in terms of x. So you had to come up here and you had to say, what does x equal? X equals y squared. All right, and we still are not doing top minus bottom. So you're not doing y squared minus 0. What are you doing here? Yeah, or really 4 minus y squared. If you wrote y squared minus 4 here and you typed that in your calculator, how would you know that you got it mixed up? The answer would have been negative, so you go, oops, I got this mixed up. I need to switch this around so that my work shown is accurate.
Why is it 4 minus?
Because the right function is 4 and the left function is y squared. You always want to start with the one that's like more positive. And so in terms of y, the 4 is more positive than the y squared. Okay, and if you type that in, you would also get 16/3. Definitely encouraging you all to do this part on your own. Okay, so if we were doing cross sections, really the only thing that would be different is the body of this integral. If this was a square cross section, we would square it. And then if we have equilateral triangles, we'd put like √3/4. Okay, that's all the stuff that we did before. Okay, but with revolving, we're going to need to first draw a picture. Okay, I'm going to change, I want a little bit more room here. Okay, so the first thing I want you to do down here is to draw this picture. And you don't need to draw all of it, just kind of the main part, which would be that right there. And then since we're going to revolve around the x-axis, I'm going to draw a little circle arrow there. And I'm going to show you a model here, and then I'm going to show you a computer kind of interactive simulation that you can use if you find that helpful. But the way you're going to visualize it, like when I'm not there and you don't have a computer program, is you're going to first just reflect. Reflect across the line that you're rotating around. This is going to give you an idea as to the 3D shape. So can you visualize this shape? What does this look like to you? Kind of like a sideways rounded cone or a bullet, maybe?
Bullet.
Yeah. Okay, so that if that gives you this 3D shape. Now, once you draw this reflection and imagine this 3D shape, here's a couple of things we need to do. First of all, is this with respect to x or y? You can look up at the top of your paper if you need a hint. To x, good. And then because this makes a very solid, there's no gap at all, this is going to create this is going to be a circle problem, which is pi little r squared. All right, let me show you the circle that I'm talking about. If we were to kind of turn this around so that I was looking down, basically the tip of that bullet, it would look like a circle. Okay, and that would be my circle, and my radius would be right there through the yellow part. Okay, so the radius would be something I'm already familiar with. With respect to x, it would be square root of x minus 0. We kind of look right back up here. Circle problems are going to be a little bit easier because the r in a circle problem is the same thing we dealt with when we did with s. Washers are going to be more complicated, but circles are going to still be pretty basic. Okay, so let's find our volume. If you've done this setup, the rest should be easy. You have your pi. Always bring the pi to the front of the integral. We can do that because pi is a number. Make sure when you're doing your bounds that you're doing that with respect to x or y appropriately. we've already figured out what the bounds are with respect to x. That's 0 to 4. That's going to stay the same. Okay, now in the inside we are going to have r squared. So I'm going to write square root of x minus 0. Of course, you could leave out the minus 0. There's no problem with that. And if you type this incorrectly, you should get 8 pi. The best way to know that this particular problem is a circle and as opposed to a washer, and we haven't even done a washer yet, is that an edge of the shaded part, the base, is the line of rotation. So it matches up perfectly. Now that's going to all change here with part B. Okay, so if we look at part B, first thing we need to do is to draw the picture. Okay, same, all the same things. But we're going to rotate this differently. So here's our x-axis. We need to rotate it around the line y equals -1. Now, I cannot stress enough how important it is that you don't get vertical and horizontal lines mixed up. If you do that, everything is going to be wrong in the problem. You've got to make sure you keep those straight. All right, so in this next one, we're rotating this not around one of its edges, but around some other line. So when I reflect, first of all, you're going to see the gap. And if I revolve this around, it'll still kind of look like a bullet, but the middle of it will be completely gone. Okay? Kind of like a bundt cake, if you know what a bundt cake is. It has a big hole in the middle. All right? So it does sound good. All right, so when I try, the rotation direction is the same. So this is still with respect to x. However, this is going to be a washer problem. Now, if you're like, how do you know that? I know that because if I imagine this 3D figure rotating around this line, there's a big hole in the middle, okay? If I try to draw a circle, go ahead and go all the way, top to bottom, edge, top edge to very bottom edge, and you can see that there's a whole gap right here. And if I draw it, it looks like that. And so we get what we get is a washer. Okay, when you do a washer, the formula is different. It's pi, big R squared, minus little r squared. And I will tell you, the big R and the little r, neither one of them is square root of x minus 0. This is totally different. So this is going to be the big question of the day, and we're going to have to talk about this probably more tomorrow. So hold your questions off until I get done here, and then we can kind of go over questions. But I will tell you, we're going to have to just do a lot of examples before we get really good at finding big R and little r. But neither one of them is the same as this little r from the circle. Okay, big R is going to be from the center all the way to the outer edge. Okay, so where's the center of this washer? It's on the line of rotation. So you need to use that -1. So see how the top edge is root x? And we're going to go minus, not 0. We're going to go to the line of rotation, -1. If you want to change that to +1, you can. I'm not, just to really show that I'm still subtracting something. Okay, little r then is going to be from the inner edge. Okay, and the inner edge here, okay, would be 0 and to the line of rotation. So 0 minus -1. Before you ask questions, I want you to consider something. Both of these are minus -1. That should always happen, that they're minus the same number. It could be that the -1 should have come first if the line of rotation was like above, if that was the top one. Getting these mixed up though, it's actually really easy to figure out if you get them mixed up. because when we put this into our volume, okay, we still have pi in front. We're still with respect to x, so it's still 0 to 4. Okay, we need to do big R squared. Look at what I'm doing here. I'm putting something in place of a squared. If you accidentally switched up the -1 and square root of x, if those were in the opposite order, would that actually really matter if you're squaring it? No. So that's a common mistake, but it would not be, it actually wouldn't affect your problem at all. Okay, big R squared minus little r squared. And so little r squared is going to be 0 minus -1. And again, if you got these two things mixed up, you're squaring it, so it doesn't end up mattering. Now, what if you got all of big R mixed up with all of little r? Would that matter? Yes. How would that affect your answer? Your final answer would be negative, and you'd go, well, that didn't make sense. I know my final answer should be positive, and you could go back and fix that. So there's a lot of these things that you can kind of self-correct if you know what to expect. Okay, both big R and little r had a minus. They had the two parts that we subtracted before, and they had the line of rotation in both of those parts. Okay. All right, let's do the next one. So guess how we're going to start this? We're going to draw the picture again. And you can be as detailed as you want in this picture, but really it's just a means to an end. So there's our shaded figure. This says we're rotating about the line x equals 4, which is conveniently this edge right here. Okay, so we're rotating right here. And if you need to label your x and y so you can remember which one's which, and that this is the line x equals 4, do that. Make your picture as detailed as you need it to be. All right. Do you see how this is going to create a different type of rotation than the other two? Yeah. Okay, this is going to be a with respect to y. The circle that I draw is going to be horizontal here. We're still going to do, though, like what we did before. Your line of rotation, I want you to reflect that yellow shaded part across the line. Now, if that shaded part is buddied up right on your line of rotation, perfectly, shares an edge with the line of rotation, you should have a solid figure in creating a circle. If there's a gap, you should have washers. Which one do you think is going on here? It looks like a circle. So I'm going to draw this and I'll show you the figure. Okay, this right here, you know, before we were just drawing something like this. What that's representing now is the radius of this circle. And I'm drawing it like an oval because I'm trying to get some perspective in here. And if I could twist and turn this so you could look at it from different angles, I would. But I can't do that on paper. But you're not going to be able to do that either. So eventually we're all going to have to be able to do this on 2D paper. All right. And so this is a circle, which is pi r squared. And when you get a circle, your little r is the exact same thing as s. Don't overcomplicate it. Washers are complicated, and we have to deal with them. Circles are not that complicated. Okay, so remember when you did area up here, and you did with respect to y? See how this was 4 minus y squared? That's what your little r is. It is if I look right here at this r, it is 4 minus y squared. You have to do this in terms of y because of the direction of the rotation. All right. So even if you're kind of lost at this point, what do we always start these volume of rotations with? Pi. All right. Then our bounds depend upon if we're doing this with respect to x or y. We're doing this with y. So look back up to the first part if you need to. What are my y boundaries? Not 0 to 4, 0 to 2, because it's bottom to top now. And then r squared would be 4 minus y squared squared dy. Please do not forget dx and dy. You're going to lose a point when you forget that stuff. And again, I'm just going to give you the answer. You need to make sure on your own time that you can type this in and get the same answers. Okay, for part D, we start the same way. Let's draw the picture. I would never suggest you try to do all parts A, B, C, and D all on the same picture. It's going to be too messy. Okay, this time we're revolving around the y-axis. So remember, the way you're going to determine whether this is with respect to x or y has to do with the direction of the rotation. Okay, this is a horizontal rotation. It's going to rotate horizontally, which makes it with respect to y. And if you're not sure whether this is a circle or a washer, you need to first off draw the reflection. All right, now is there a big gaping hole in the middle? No. However, think about what this is going to make. It's going to kind of look like a cake, and I don't have a model for this. It's going to look kind of like a cake that totally sank in the very middle, all the way to the bottom.
A crater.
Yeah, kind of like a crater. So I would say a bundt cake, but a bundt cake has an actual hole in the middle. This is not really a hole in the middle. It just, at the very center of the cake, it's like punched in right to the bottom, but not through it. Okay? So that's how you know. This is one where it's like not as obvious if it's a washer or a circle. So if I think about it, if I draw this circle that goes all the way from one edge to the other, I have some gap here in the middle. All right, that's going to give me a washer. Okay, that's how you know. That's half the battle. Just knowing it's a washer. The other half is figuring out big R and little r. Neither one of them is going to be 4 minus y squared. I'm going to use 4. And I'm going to use y squared, but one's going to go with one and one's going to go with the other. So if we think about this washer, okay, big R is going to be from the line of rotation all the way to the outer edge. Okay, the outer edge is x equals 4. The inner edge is x equals 0. That's big R. It's all the way from the line of rotation to the outer edge. So if you were like, should I write 0 minus 4 or 4 minus 0? In the end, it won't matter because this thing is going to get squared. Technically, though, the 4 is the bigger one. That's more obvious when it's numbers. It's not uncommon for big R and little r, one of them to be only numbers and one of them to be functions. It could be where they're both functions, but... Okay, little r, so remember the inner edge, what did we call the inner edge with respect to y? Y squared. And again, minus 0. In a washer problem, your little r and big R should have a commonality of minus the same number or the same number minus that. Once you have this set up, you should be able to write the volume. Write your pi. Make sure you're sticking with your with respect to bounds. So the y bounds are 0 to 2. Your big R squared minus your little r squared. If you're getting the things inside the parentheses mixed up, like 0 minus 4 or 0 minus y squared, that's okay. The squared will even it out. If you get the big R and little r mixed up with each other, you will know because your final answer will be negative. So this was kind of our first example. Let's do another one. I'm going to go through that one a little bit quicker. Okay, on this first one, or this next one, we are not going to just go ahead and find the area first. We're just going to jump into the volume. You're still, though, going to need to graph. What shape would 2x squared make? A parabola. Y equals 0 is x-axis. X equals 2 is a vertical line. The graph is there to help you do the next part, so make it as accurate as you can, but it doesn't have to be a masterpiece. Okay. Oops. All right, so we're rotating around the x-axis. Does my shaded figure, well, let me back up. Is this with respect to x or y? X. And to know what our rotation really looks like, draw the reflection, kind of a dotted figure, and you can see that I share an edge with the rotation line. So this is going to create a solid figure. This is going to be a circle. If there's a gap in the middle, then we'd have a washer. Circles are nice. They're pi r squared, and r is the easy one. It's just going to be the same thing we do when we get area or cross sections. So what do you think r is in this problem? So think about that. This little part right here. Here's the circle. What's the radius of the circle? 2x squared minus your line of rotation is not 2. What's your line of rotation? 0. So my volume is going to be pi. What about the bound? What are the x bounds? I skipped that part here. So this is where you're going to get that x equals 2. X equals 0 to x equals 2. Those are your bounds. And then you don't, of course, have to write minus 0. You get here 128 pi over 5. Okay, circle problems. I'm not saying they're easy, but they are easier than washer problems. Don't make them more complicated. On a circle problem, the little r is the exact same thing as s was in our previous.
That's the same answer we got on the last one.
Yeah, that's okay. That's happened sometimes. Like 9/2 and 16/3 come up a lot. There's just some answers that come up more than others.
Okay.
So if you were to, okay, here's my solid figure, right? That's going to be little r right there. From the middle to the outer edge. The outer edge is 2x squared. The line of rotation is 0. So top minus bottom. Okay, y-axis. What do we already know is changing here? This is already going to be with respect to y. So as soon as you figure stuff out like that, then go ahead and write it. Now, I know what this shape looks like. You can draw more if you need to, but notice I'm just kind of getting the basic part. I'm not drawing anything else that I don't need to because the graph is already messy as it is. Okay, so here's the y-axis. I'm going to rotate around the y-axis. If you're not sure if this is a circle, excuse me. If you're not sure this is a circle or a washer problem, you need to reflect. If you reflect that shaded part across the line of rotation, it should give you an idea of what this figure looks like. And the more you visualize these things, the easier that part gets. I wish I could make this easier for you than it is. All right, so that's rotating around. And this is looking kind of like our cake problem, except the concavity is different. So it's almost like one of those glasses, that it appears to be a cylinder on the outside, but on the inside it's more curved because there's like thicker glass down at the bottom. All right. So do you think this is a circle or a washer problem? A washer. If you're not sure, it's probably because it's washer. All right, and so I'm going to write the formula down again, and if I do this every time I have a washer problem, I will know that formula really well. So I need to figure out big R and little r. Little r is not going to be the same as up here. First of all, I'm with respect to y. So we should probably go ahead and take this opportunity to get x by itself here. Because if I want to call on this curve, I need not to use 2x squared. What is it going to be instead? Yeah, square root of y over 2. And if you wrote it slightly different, that's fine. Okay. So here's what my washer is going to look like. Okay, outer edge to outer edge circle, and then inner edge to inner edge circle. And it ends up looking like a washer. Okay, big R is going to be, keep this, the line of rotation is part of your big R and your little r to the outer edge. So this is x equals 0, this is x equals 4. So what's big R? 4. Oh, thank you, sorry. I did that in my last class. That is a 2. I think that's just, I'm getting it mixed up with the last problem. That's x equals 2. So 2 minus 0, and if you just wrote that as 2, great. Not a problem. Okay, what about little r? Yeah, see how these are both minus 0? You should have a commonality between your big R and your little r. Either minus the same number or the same number minus it. Also, with respect to y, my bounds are not 0 to 2 anymore. What are they? 0 to... So in this figure, what are my y values? Y equals 0 to y equals, goes all the way up to y equals 8. How do you figure that out? Yep, plug in 2 to that, y equals 2x squared. All right, and then big R squared minus little r squared. And of course you can simplify. There's no problem with simplifying. I'm just not going to because it doesn't really help you. It may make it easier to type in the calculator. Okay, I'm not going to finish these next two problems, but I want to show you something even without, well, let's draw the quick graph really quick. But I'm not going to do this whole next example. So here's the line, y equals 8. So do you guys think this is going to be a circle or a washer? Just already. Let's just go ahead and do big R and little r, and then we'll call it quits on this lesson. Is this with respect to x or y? X. So here's your washer right here. And as you draw it, this is going to help you find your big R and your little r. Your big R is going to be from your line of rotation to your outer edge. What would that be? What's your line of... See how the line of rotation this time is above? We're going to go 8 minus 0. If you wrote this as 0 minus 8, it would be okay because you're going to square it. And then little r should also have 8 minus. They should both have that because the line of rotation is 8. 8 minus what? Should I write it as 2x squared or square root of y over 2? 2x squared because of the whole with respect to x. All right. I'm going to end here, but I want to show you something. If you go to my timeline, you go to today and you click this interactive revolution, it's going to take you to a website and you can put in any, so anytime you're doing these on your own, you can put these in and you can change the color and you can revolve it. If you notice, see how it's doing the animation? You can make it revolve. This is the one we did in the notes. And then if you grab this, you can turn it and look at it from different directions. So those of you that are really having a hard time visualizing this, I think this is something that would be a good use of your time. Okay? All right. So please use that as much as you